Huh. Okay. All right, so I'm not going to see their little faces.
Well, no, because I'm sharing my screen, so.
Gotcha. Okay, that's
Right.
fine.
Okay.
All right. Now, can they hear me?
Can you guys give a thumbs up or say hello if you can hear Vicki?
Hey, Vicki and Joe, we can hear you.
Okay. All right, good. All right, well then, let's get started. Let's start, excuse me, on page 38, chapter 5, water systems. So look at the artist rendering on the bottom left, water supply systems in a cold climate. And this is pretty much how we function here in the Philadelphia area. So on the far left, you see the street curb because the water main is in the middle of the street. So that's where that is. Oddly enough, Philadelphia still has very old systems up in Germantown area, way up there, parts of Chestnut Hill. Their water supply systems are still wooden pipes. I know it sounds crazy. The only reason I know that is my son, when he first got out of the Marine Corps, worked for PGW. And so the gas lines run often parallel with the water lines in the streets. And that's how he actually saw the wooden piping that was put in hundreds with an S, hundreds of years ago. So very interesting. Okay, so we have the street curb, and then you'll see where it says the curb valve. So there's a water line that goes directly from the main in the middle of the street to the curb valve. And that's where there's airflow, and there is a disc, probably 5 inches in diameter or so, flush with the sidewalk that allows air to go into the system to help move it. And from there, it goes through the foundational wall into the home, where there should ideally always be 2 valves, one before the meter and one after. Or if this was more of a slab situation, the piping would come under the foundation, come up through the foundational flooring, and so then it goes vertically rather than horizontally. And then there's a valve before the meter and after the meter. So generally, this is how it works in the Delaware Valley area, okay? It's very important to have valve shutoffs wherever you're at. So before and after the meter is the most ideal situation, and on a home inspection, you will hear, excuse me, the home inspector making a comment about the meters having a shutoff before and after. If you go to page 39, it talks about a well pump and well pumps that are submersible and well caps, of which you're not going to find in the city. But with that said, do note, excuse me, if you accidentally sell in the suburbs, you will be or could be dealing with wells. It's very important that you don't have a buyer try to convince you that they don't need a well inspection. Every property with a well has to be inspected. So it's not even up for discussion. It's a must, okay? So it goes on to talk about well pressure tanks that we're not going to deal with. And it then goes on to, on page 42, if you could flip that, Joe, to page 42. On the bottom right, we're going to talk about the typical water heater, a gas system. On the next page, there we go. On the bottom right, so those of you who were in my class last week, and we talked about hot air systems, there's some similarity in the functionality of a water tank and a hot air system. It's not a hot water tank. Your water heater is a water heater, not a hot water heater. It creates hot water. So when we look at the structure on the left-hand side, you see the gas supply line coming down. And that was identical to what was on the hot air system that we spoke about. The gas supply line comes down. There's a gas shutoff valve, which is black galvanized material. And then you'll see it makes a 90-degree turn and turns into the unit. Below the 90-degree turn, there is continuous piping, 3 to 4 inches long. As we spoke about last week, that additional piping that is below the 90-degree turn is there for the purpose of, if there is any water in the gas line, water is heavier than gas, so the water would drop to that little extension pipe and not enter into the unit itself. When you're at a home inspection and you're looking at a water heater, look and see if the extension pipe is there. If the extension pipe is not there, that's telling us that Uncle Joe, or famous Uncle Joe, has been there, which is someone who's been able to hook this up, but is not of professional quality. When it makes that 90-degree turn, you're going to see that the temperature control valve is right there also. And that's how you determine how hot you want your water to be. So now, how does the water get in the tank? Well, if you look on the right-hand side at the top, this is where the cold water comes into the tank. And there's a shutoff valve there. The shutoff valve is there in case the bottom of the tank should leak and rust out, and the water is just pouring in from the top, coming out the bottom. So that's your availability to stop feeding the tank water because it's leaking out the bottom. So that's where your shutoff valve is. So when this is functioning properly, the cold water will always enter into the tank as needed. When you are demanding hot water, so it's 7:30 in the morning, you get up, you mosey into the shower, bathroom, you turn it on, and now you're waiting. It's on demand. You're demanding hot water. So we're waiting for the hot water to come from the tank and go up the pipe on the left-hand side. It's hot water out. So now you're demanding water to the second floor, because we're basing a lot of this on a very typical Philadelphia structured home, 3-bedroom, 1-bath, 2-story home in South Philly. And so now you're trying to get the water up from the tank, through the basement, through the first floor piping, up to the second floor. So this is how it makes its exit, out the top of the tank, on demand, and going to where it is needed. So it's going towards the shower because that's where you're asking for it. So it's going to take a few minutes. All of a sudden, you're now feeling the heat of the hot water. So you're like, okay, here we go. As the tank starts to empty, at a particular level, the tank needs to be refilled, and it knows it needs to be refilled because it's on a demand system and is pulling up the hot water because it's being demanded for. That's when the cold water now comes in, and that pipe goes to the bottom of the tank where the burner is. The gas burner is there, so it is now starting to heat the water. This is how the water gets heated when it is re-entered into the tank, and it heats the water from the flame of the burner at the bottom of the tank. And that system keeps repeating itself. Cold water goes in, hot water comes out. Now you'll note at the top of the tank, there is this corrugated-like bent piping that says to the chimney. We spoke about this in our heating system last week. And the question was, why is there a pipe going to the chimney? Well, we've established that gas and oil expel carbon monoxide. Carbon monoxide is our CO2, which is a poison. So this system has to expel the CO2 and force it out the chimney to remove it from the home. So that's why that piping is there, to remove the carbon monoxide. That pipe is very important. In your home inspection report, the home inspector will speak about that pipe. And one of the important issues about the pipe is the pitch or the angle the pipe is to the chimney. It needs to be at a particular angle to have the chimney draw the carbon monoxide out. If the angle is incorrect, that will be noted on a home inspection report. Okay, if we look to the right of this tank, you'll note where it says temperature and pressure relief valve. This is a very important valve. This valve oftentimes is found on the side of the tank, but it also can be found at the top of the tank. It is made of brass, and the purpose of this temperature pressure relief valve is if the thermostat in the heating system, in the water heater, becomes deficient and it doesn't shut off and it continues to heat the water to a boiling state, the temperature can build up within the tank to a point where State Farm Insurance used to do a commercial where the camera was across the street looking at a cute little Cape Cod. And all of a sudden, out of the chimney of this Cape Cod come flying out a water heater. That is very true. The pressure in a water heater can build to a level that it can explode and eject up to 2 stories in the air. That's like for real. So to prevent that from happening, they have a temperature pressure relief valve. Now, the temperature pressure relief valve is about 4 feet up the tank. If an individual was to walk by the tank at the exact moment that that temperature pressure relief valve was to release because of a deficiency in the thermostat, and to release the pressure, it will spew out scalding hot water. If that's to happen when an adult was walking by, it would hit them in probably the chest area. If a child happened to be walking by, or an extremely short person, it would be hitting them in the face. That is why an extension pipe is recommended. On an FHA VA transaction, it is mandated, though, that an extension pipe be added to the temperature pressure relief valve. On a conventional loan, it is not mandated, but the home inspector would be recommending it. It is extremely inexpensive, and it can be PVC piping. It does not have to be copper. And it's a male-female fitting. So the fitting inside the brass temperature pressure relief valve is a female fitting, which means that the threads are on the inside. So you would want the threads on your PVC piping to be on the outside so that you can screw it in. That extension pipe should be long enough to come within 6 inches of the floor. So 6 inches, it should go all the way down to within 6 inches of the floor. There's also a drain valve at the bottom of your typical water heater, and that is there to empty the tank if needed, or if the tank should develop a leak. You could expedite the removal of water by attaching a hose to it, opening the valve, and the water in the tank can be removed through the hose into the utility sink. Okay? Now let's look on page 43. 43 has a very good chart at the top left for water scalding. So people with small children, it's important that you are conscious of the temperature that your water is at. It shows that 120 degrees, it would take 5 minutes for serious burn on someone's body. Yet 10 degrees higher at 130, it would only take 30 seconds. 5 seconds for 140, 1.5 seconds for 150, and at 160, about a half a second. So the temperature is regulated on a gas system on the outside, but it's important to be cautious of where that temperature is being set at. So if someone is in a home with small children, they're going to be extremely cautious of where their temperature is positioned in that system. Just below that, it shows the interior parts of a water heater that is electric. Now, some of the similarities are there that we saw from the gas-fired system. At the top, we have the water coming in on the right and going out on the left. And that's exactly how it shows on the gas system. At the very top, we have the electrical feed. So this is the electrical current coming in to power the system. You'll note that there is no large piping coming out going to the chimney. The reason there is no piping going to the chimney is because there is no carbon monoxide developing from electric. Electric does not throw off carbon monoxide. So therefore, we don't have to send any air up and out the chimney. It's not forming in an electrical water heater. The access panel for the thermostat is often closer to the top. It could be lower. They're showing both here. But generally, the electric water heater, there is a plate you have to unscrew and move the insulation. And that's where you can adjust the temperature for an electric water heater. That is an electrical rod, sort of a U-shaped rod in the water heater that heats the water on demand. So as we had the heat source being gas before, and you saw the flame at the bottom, this rod that heats the water is closer to the top. We also have a shutoff valve for the cold water coming in, just like we did for the gas. And we have our temperature pressure relief valve, as we did before. We also have a drain valve, so you have the availability to drain the unit if need be, but the concept of the two systems work the same. On demand, water, hot water will go up and out of the system when needed. Okay. Let's look on page 44. If you could move that, Joe, thank you. On page 44, it talks about your temperature pressure relief valve again, which we spoke of. And it talks about your thermostat dialing system. It gives a photo of it on how on the outside on a gas system, how you can increase the heat. It also shows a water heater oil-fired. I have never seen an oil-fired water heater. When gas is not available, often, or at least for me personally, I've only seen electric. But there are out there, and there may be some homes that do have an oil-fired water heater. Things to remember. There's your big piping going up through the top to the chimney. Oil throws off carbon monoxide. So we have to, again, have the carbon monoxide expelled away from the home. So that's why that chimney is now pointed towards and being attached to the chimney area. Okay. Okay. Let's turn to page 45, and it gives an illustration here, sort of a slicing of a house, how the water and the pipes work from a basement type style home. And it shows how the water is coming into the house. Now this one shows it coming under the foundation and up vertically. There's a main water valve shut off before and after the meter. Then the water continues to come up and goes across the ceiling of the basement and then comes down to feed into our water heater. Now this one shows to be an electric system, and the water is coming in and then the water is coming out. When the water is coming out, though, you'll note that as it comes out, it has to go in a particular sense of order. So when the water is coming into the home, it passes the meters, it goes across the ceiling of the basement, and either T's, there's a T piece in there, either continuing going down the road or it drops down into the water heater. If it continues going down the road, there's another T going up, and that cold water is going up to refill the toilet when needed. So there's the source of the water for the toilet. Or if it continues to go down, you'll see that it tees up for the cold water in the vanity and then continues on to other T's in the flow of the piping for where water will be needed. Note, though, the hot water that comes up and out of the water tank, the water heater, comes up and makes an elbow here in the illustration and then tees up to the hot side of the hot cold faucet. So one is supplied directly from the cold water coming up into the home on a demand system, and then there is a specific piping for the hot water, two separate entities approaching the either toilet and or the vanity in this illustration. It shows the same in the artist rendering below on page 45, the same illustration except squatty, because this is scaled down in height because we're in a crawl space, but the functionality is all the same. It all happens the same way. It's just that the water heater is shorter in height than it would be for that of a full basement. When we turn to page 26, Joe, if you could move that for me, thank you. You will see a water distribution on a slab construction. On a slab construction, you'll see all this piping is in the slab. The concepts are always the same. It's just that we're not going to see the pipe because it's in a slab. Look at the metal distribution piping illustration of lead. Lead is a soft color, preformed bends with decorative fasteners. This was in the 1900s. This was the way water passed through our homes and into our homes. In the 20s, the lead was removed as newer construction happened, and galvanized steel, silver coated over steel piping. It was a screwed in fittings, so you could see the threads they show you. And that's how water passed through the house. In the 1950s, we moved to copper. which is a brown in color. It is soldered material. To make the materials stay as a closed system, they had to be solder closed. There were no threads in copper systems, or I should say there are no threads. And when there is a deficiency in the solder and moisture is becoming an issue at the joint, you will note a green corrosion that starts to happen. We also have plastic piping known as PVC. PVC is often found both in our cold and hot water distribution, but PVC comes in white and it comes in black, and it's often used as a replacement for the sewer lines in homes. When a sewer line is replaced from the old terracotta, it's replaced with a PVC piping. And then we have what is known as PEX. PEX is a manifold type of system, and you'll find that in newer construction. Kind of reminds me of a spinal cord. Is the main center of a vertical, maybe 8 inches across and 2 feet high, of which off of that branch off all of these flexible tubes. Red on one side, blue on the other, blue for cold, red for hot. And then there's a little manifold to close it and open it. That would be where your shutoff would be, right there, for the water lines that run through the house. And that is flexible hosing type. And that's how it's generally done in new construction today. So here is a bunch of variables. It's important to note, for me personally, I use a rule of thumb for this. If the home is 90 years or older since it was built, make sure as a buyer's agent, you ask the home inspector, what material type is the intake pipe coming into the home? What type of material is the pipe feeding the home with water from the middle of the street? That's an important question because it could be lead. And if the intake pipe is lead, then additional testing will have to be done. Now, when you're writing up your offer on an older property, and it's 90 years or older, I strongly recommend that your buyer chooses to elect water service as an inspection. Reason being is that if the home inspector comes back and says, yep, that is lead pipe coming in, you will now need to have an EPA certified water testing company to come out, get the water, take it back to the laboratory, and have it tested for lead coming into the home. That you will need additional timing on your home inspection. Remember, time is of the essence. And in most cases, buyers are choosing 10 days to do their home inspection. It's going to take a minimum of 12 plus days to get the results back from the EPA certified company. That is so important. It must be an EPA certified company to whom draws the water, tests the water, and you get the results back from that company. If there is no lead in the water, mazel tov, life is good. But if lead does come back in the water that is being fed to the home by a lead pipe, then there's going to have to be arrangements made because we cannot have lead coming into the home. So options are the lead pipe is removed from the home all the way underneath the sidewalk, all the way to the middle of the street. Costly. The further the house is from the curb, the greater the cost. Or there is a filter system that can be put inside the home. And I don't recall if it's before the meter or after the meter, of which will remove impurities such as lead from the water coming into the house. So these things have to be addressed if the house should pop hot for lead in the water. Okay, things to remember. It talks about on page 47, different types of valves. You know, you're going to hear these terms: ball valve, gate valve, globe valve, saddle valve, hose bib. Talks about water softeners, which is not something customarily that you're going to find with public water. Joe, if you could turn that to page 48. And what you will see on page 48 and on page 49 will be different type of water softeners. We're not going to dwell on this since it's not commonly found in the city, but if you've accidentally sold in the burbs, you may be running into this. Again, like I said in the first class, you need to read through this entire booklet so you have at least once heard of a lot of these things and have some familiarity with them. On the bottom of page 49, we're going to talk about, excuse me, garbage disposals. Joe, if you could turn that page. Garbage disposals are something most of us grew up with, and there may be a handful of us who have not, but things to remember about garbage disposals are: there's more times than not, the control switch is on the wall, on the backsplash in the kitchen. There could be an on-off switch under the counter, under the sink. When you open up that cabinet door, it could be mounted there. And there is a very particular type of screw-in attachment at the hole of the garbage disposal where you can turn it on by screwing in this attachment that then kicks on the garbage disposal. It's a safety type of device. You don't see them very often. What you will see is the switch up on the wall where the backsplash is, and or the switch mounted under the sink when you open up the cabinet door. Now, garbage disposals are electric, so it's a motor. It has to be fed electricity. It is attached to the sink, and an important concern with this is that when the garbage disposal is being used, you need to be running water constantly. Constantly to allow the chewed up food to be passed through the piping. You also need to be running cold water. And the reason why you need to be running cold water is because it's a motor, and the motor is working very hard to grind up the food that has been disposed into the system. So you don't want to overheat the motor. That is why cold water is used to help keep the system cool as possible. Now, the garbage disposals come in multiple strengths, from as little as 1/4 of a horse up to and greater than 1 horsepower. I would recommend, if you ever have to replace a garbage disposal, spend a little extra money and get the biggest horsepower you can get, especially if you are replacing a garbage disposal in an investment property. God only knows what tenants put in there. So a 3/4 to a full horse capacity is highly recommended. Now you'll note how in the illustration on page 50, you see the garbage disposal motor, and then it shoots out into the U-trap and then continues up and out, which will then go to the sewer line and go out through the sewage system. Not every type of food can go in a garbage disposal. You're not going to put corn cobs. I would not recommend potato peels if they're doing a lot of them for sure. Scoop them up and put them in your garbage. Do not put shrimp shells. I learned that lesson. The shrimp shells will clog your pipe. Bad juju. Don't do that. So throw out what you need to throw out. But yes, some things obviously can go down there. Maybe the stems of broccoli might be too much, so let's throw them out. There's also a reset button. If the garbage disposal is to get stuck or clogged, there is a reset button underneath. And then there was like this Allen wrench tool you'll see on the next page called a service wrench that is inserted into the bottom of the garbage disposal. And that garbage disposal, you then can move the blades carefully to dislodge. I will tell you though, the newest garbage disposals apparently do not have this feature. I don't know if that's a good idea or a bad idea, but newest garbage disposals from my home inspection with new construction indicate that they don't have that feature any longer. I want you to look on page 51, and we're going to talk about the hose bib. Now, the hose bib is what is called the faucet outside that you hook your hose to when you want to water your yard or wash the car. Now, this small area of piping can become a big problem as the temperature changes outside. This is a very good opportunity in October to reach out to your clients as a touch. We need to touch our clients and remind them that we're here. And in October is a prime time to reach out to your clients and remind them to drain their hose bib. So let me give you the general understanding of how this works. Where the hose is outside of your house, that pipe will run through the foundational wall into your home. So now you have to figure out where that's at. So you go outside and you see where the hose is. And now you have to figure out how close is that to the steps? How close is that to the window in my basement? How can I judge where to start looking for this in my basement? You then get in your basement and you look up. You look up to where the piping is in the ceiling of the basement. And you follow to see that there is a particular pipe that goes out the foundation of your house. Either the side of your house, the front of your house, the rear of your house, wherever this hose bib is. Now you've identified where that pipe is. You will also see, following the trail of piping, that there's a shutoff valve. You need to shut off that valve. Now that you have shut off that valve, you have inhibited any additional water coming through the house to pass by that valve and continue on to the outside of your house. You've shut it off. No more water can pass that valve. You now take yourself back outside and open up that valve in the backyard, in the front of the house, on the back patio, wherever you're at, and allow the water from the shutoff valve to pass that's going through the foundation of your house to the valve itself. You want to remove the water, those 4, 5, 6 feet, whatever it may be. Now that pipe is empty of water. When no more water comes out of the pipe, you now shut the valve outside off. So between the two valves, the one outside and the one inside you have shut off, there is no water remaining in that pipe. Reason being, the water that remains in that pipe when the outside temperature gets below 32 degrees will freeze. And if it freezes, freezing expands. Cold expands because it gets frozen. Cold water expands because it gets frozen. And it will fracture the piping, causing a crack in the pipe. And now, once the outside temperature is above 32 degrees, you're going to have leakage. You're going to have a cracked pipe that is leaking water in your home. That's when you get that phone call, probably in around March, and your client is asking for a plumber because now they have water dripping in their basement. Okay, so this is a great time to review this with especially first-time home buyers. It's important. Plus, it's important just to remind your clients to drain their hose bit. Okay? It talks about on page 52, if you could move that page, Joe, thank you, about water hammer arresters. Those of you who grew up with hot water heat, radiator and or baseboard heat because you had a boiler system, not a hot air system, sometimes would hear banging in the wall. That's because there was air in the line. This attachment can be added by a plumber to allow air to escape through the closed system. You don't see them very often, but they are available. On page 53, when it talks about drain, waste, and vent pipings, to have water move out of your home with brown water, so that would be the water that's going through your sewage system, has to have a venting system, an air to allow it to pass and to remove sewer gases. That's why these pipes expel high on the roof line. So you'll see that things that have to be attached to a sewer line, such as a toilet or a vanity, a utility sink, they all hook up to the sewer line going up and out of the roof line. These are how water moves through. You'll also notice on the sewer line, there's a clean out valve in the basement area, somewhere near and hooked up to the sewer line itself. It's made available with a screw on top so that if there should be a blockage in the sewer line, that the plumber is able to put a snake in there and hopefully move the object that's blocking the sewer line. It talks about an air valve on page 53. But what I want to show you is this illustration of a sink. The slice of a sink, you'll see it has water in it. And then that pipe goes vertically down into a U-trap. The U-trap is there to prevent sewer gases from backing up into a home. Let's talk more about that on page 53. And on page 53, on page 54, next page, you'll see it has a good illustration as the floor drain trap is the same as it is a U-trap under a vanity or kitchen sink. The purpose is so that once water comes down the pipe and pushes itself out into the sewer line, there will always be a remainder of water in that U shape to prevent the sewer gases from backing up into the living space. Sometimes when you're working a home that has been vacant, for a long period of time, you can walk in and you'll notice a foul smell. The foul smell could be because there's a crack in the sewer line in the basement, or maybe the water in all of these U-traps, the sinks, the toilets, the vanities, the utility sinks, have evaporated because they have not been used in quite some time. Therefore, with the evaporation of the water, it's allowing the sewer gases to come up into the home. You'll notice on the illustration on the sanitary sewer cleanout, it's showing again a couple variations of cleanouts. So more than one place oftentimes is available for the plumber to clean out a sewer line if needed. When you look on page 55, though, the illustration on the left, we're going to be showing here how and the difference between storm water and sanitary water. Brown water that comes from the home that has to go through our septic system is from our toilets, our sinks, our utility sinks, the discharging of our washing machine. That goes all into our sanitary sewer lines. But you'll note where the downspout is. As the water comes down the roof line and goes into the eaves, or the gutters, excuse me, the gutters go down into the eaves and into the storm sewer. The storm sewer is totally separate from the sanitation sewer line. The two should never meet. They are two separate collections of water. One is the rainwater and surface water into the storm sewer, and the other is the sanitation sewer, two separate entities. We'll talk about a septic system on the top of page 55, where we have a septic tank. Now, septic tanks are found in the suburbs, and how this works is when you flush that toilet, the wastewater comes down the sewer line and it goes directly into a holding tank, which is known as a septic tank. In the septic tank, there is variable layers, which consist of sludge on the very bottom. And then we have a water table. We have scum on the top. And then there's going to be an outlet above that. So what is happening here is, as we use brown water, and as brown water is filling the tank, the solids drop to the bottom and the brown water floats to the top. At some point, when the tank volume becomes smaller because of the scum at the bottom is getting taller, there needs to be an overflow. And the overflow of the brown water will come up and out another piping through the back of the tank. And that is where they illustrate here as a field. That field is where PVC piping is with a lot of holes. And the brown water will continue. There are no solids, it's just water. Will continue out to the leaching field. That's what it's called. And it has all these PVC pipings with little holes, and it allows the water to seep out to relieve the pressure in the tank and then drain through the earth itself there. Now that's where the grass grows the greenest. That's where you do not want to put your garden, near the leaching field. Okay? Never ever have a buyer say to you on a property that does not have public sewer system that they are not paying to have the septic system inspected. This is not even up for discussion. A deficiency in a septic system can run $3,000 to $30,000 in repairs. It's no joke. So it is mandatory that a home that does not have public sewer have the tank inspected. It goes on page 56 to talk about a mound septic system. This is known as a sand mound. Those of you who have spent time up in the Poconos or maybe have rented homes or have family with homes up there, you'll note oftentimes in the backyard, there's this big mound, and that's known as a sand mound. And the concept of the system is the same. The brown water leaves the home, goes into the septic system, and when it has reached a level that the brown water doesn't fit in that tank any longer, instead of it going to a leaching field, it goes to an underground tank, of which then pumps the water up into a mound further away from the house. This is known as a sand mound. At that point is where the water then leaches with all those little holes into the sand and purifies as it drips down through all that sand and into the soil. If the home has private septic and private well water, these two will never be in the same place. You don't want the septic system anywhere near the well. So the well very well will be in the front of the house, and the septic system will be in the rear of the house. Or perhaps they could be reversed. The well is in the rear, and the septic sand mound is in the front of the house. But the two can never be near each other, right? Because we're counting on the sand and the earth to purify the water as it becomes groundwater again. Okay? All right. Let's look on page 57 on the bottom right. And we're going to talk about the gas meter. Now, this gas meter is very much a likening to the Philadelphia Gas Works, the PGW. It's gray in color. It's generally in the basement at the front of the home. Sometimes we will see these meters on the exterior of the home, but often are in the lower level basement of the home. They have a circular vent system to allow air to escape if air should get in the gas line coming in. And then there will always be a shutoff valve there if needed. The meter has numbers across the front. This is what you want to take a picture of, those digitals, when it is your responsibility as the buyer agent doing your pre-settlement walkthrough to get a meter reading. You're going to get the gas meter reading and you're going to get the water meter reading. So you're going to take a picture of these numbers on the gas meter and you're going to give them to you're going to give them to the title clerk at the settlement. When you turn to page 58, we're going to talk about shutoff valves. And it's important to know where the shutoff valves are for both gas coming into the home or propane coming into the home. Now, my son lives on the edge of the city. His home, halfway up the street, has gas. The second half of the street he lives on does not have gas in the street for whatever reason, God only knows. So he has oil-fired hot air system. Excuse me, I'm wrong. He has oil boiler system. He has a hot water system in his home to heat it with baseboard radiators. He also has a propane tank on his property so he can have gas for cooking and gas for his dryer. And of course, he has electric in the home for the central air and to supply electricity to the house. So he has 3 different sources of energy coming into his home: propane, oil, and electric. I want you to look on the next page, on page 59, and it talks about an oil tank. Now, this is really important. There are many oil tanks that are still functioning in the city of Philadelphia. Not everyone has converted to gas. With that said, you'll note there are 2 pipes that are exposed on the exterior part of the home. This is especially important if you're showing property in North Philadelphia and West Philadelphia. They still have the highest concentration of oil tanks. If you are showing property, these tank, vent pipe, and fill pipes are oftentimes in the front of the property, because the front of the property is how the oil company will make access with their trucks, and they pull their big oil line to fill the property when an oil drop is needed. Now, one of the tanks allows air pressure, and the other tank is the fill tank. When you hook up to the full tank, then, just like your car, when you fill it with gas, you turn it on, the oil goes down the fill pipe into the oil tank. I want you always to check. If you are noticing that there are 2 pipes outside of the foundation of this property, please check your bright information sheet, which you should always have when you're showing property. You need to print this out. Kill a tree. You need to have availability to see what's going on with this property. If you see these 2 pipes, you need to check your bright MLS sheet and confirm that the property is of oil heat. If in bright, it says that it is hot air gas heat, this can be a big concern. Get yourself in the basement and look and see if the oil tank is still there. Look and see if there is a gas hot air system there. If the heat source has been converted from oil to gas, and it's been converted from oil to gas hot air, this can be an issue. Depending on the type of mortgage, FHA, VA, if a gas system has been converted, will mandate that the oil tank be removed from the property prior to closing. Not necessarily on a conventional. Here's the other thing. If the oil tank is still there and the fill pipe is still available on the outside, the question is, has that fill pipe been abandoned properly? Such as, has that pipe been filled with concrete to prevent someone from hooking up and putting oil into the tank? Or even more scary, has the oil tank been removed and the fill pipe still shows on the outside of the house and was not abandoned properly? So if an oil delivery man is not paying attention and is at the wrong address and hooks his pipe to the fill pipe on a home that has had the oil tank removed, but did not abandon the fill tank properly and drops in 500 gallons of oil, it's landing 500 gallons of oil in somebody's basement. This is an absolute nightmare. You need to make sure and confirm that all the pieces of this puzzle are working properly in regards to oil tanks, and if a conversion was made from oil to gas in a hot air system. If you are an agent listing a property and it is a vacant property that does have oil heat, you must take the responsibility of never allowing the system to run out of oil. Old systems, old heaters, if you were to run out of oil, would seize the heating system and destroy it. The newer hot water tanks or hot water systems that are fueled by oil will shut itself off if the oil tank reaches a quarter of a tank or an eighth of a tank. I don't know where the shutoff is, but it will just shut itself off to prevent the system from seizing. Old systems don't have that safety feature. So if you got a listing of an estate and the nephew lives in Wisconsin and doesn't know anything about the oil system of the house or how it's being fed, or does it have a routine on oil droppage, you need to take that precaution and find out how this home is being heated during the cold winter months. Okay, big responsibility, but that becomes your responsibility. All right, let's turn to page 60, chapter 6, General Home Systems. And we're going to talk about different types of foundational wall. You'll note on the left-hand side, there is the artist rendering of a concrete block foundation. And it clearly shows that they pile up the blocks to the height that they need to create the basement and the foundational wall. Or is it a poured concrete foundation where a form was made when they dug the earth out to create a basement, and then the forms were filled with concrete to create a concrete foundational wall? The same thing can apply if there is no basement and it's just a crawl space, and or how it would be if it was a slab right on the grade of the earth, a slab foundation with no basement or crawl space. When you look on page 61, you'll see something that's called pile foundation. This is known as pilings and is used for poor soil conditions. Now, pilings are something we frequently see down the shore because of the sand. Sand is what we're dealing with as a foundation, and pilings are compressed down through the sand to give a sturdy foundation for a home to be built on. And they're actually pounded into the soil. Let's look on page 62, and a very important issue is talking about proper grading of the soil lines. Philadelphia is a very wet area. We are wet because we sandwich ourselves between two major rivers, the Delaware River and the Schuylkill River, of which we have a tendency to have damp basements. You'll note on the new construction illustration, they're showing a sump pump. This illustration is of a property that's on a high water table, and it is showing how a sump pump works. In that, there is a crock that is dropped below the basement line, basement flooring, and all around the perimeter of the home, there is a gully that has been dug out, lined with gravel, and pitched so that the water will drain towards the crock. When the crock fills up with water, the motor will kick on and expel the water that has built up in the sump pump to one of two areas. Here it shows the water is leaving the home, going underground, or it could be on the ground level away from the house. So this is where that extra water from the basement is now being shoved away from the house. It's being pumped away from the house 10, 15 feet away. This is what happens in the suburbs when a home has a sump pump. In the city of Philadelphia, it is legal for the sump pump to discharge into our sewer lines. It is not legal for it to discharge in the sewer lines in the suburbs. So a PVC piping has to extend far away from the house to expel the water that is being discharged from the basement of the house. Otherwise, it's just going to run right back in, right? So we need to send that water far away from the house. A simple tool that can be used when a home is showing signs of moisture penetration. It may or may not be puddling of water, but there is dampness in the basement level. Note the illustration where they have a 6-foot long 2x4. And they've taken the 2x4 and they've put it up level against the house. So you'll see they have a level on it. And they show the other end of it, and that it's sort of like suspended in air. It's suspended in air because the grading of the soil away from the house should be 1 inch per foot. That means if that piece of wood is 6 feet long, at the end of that 6 foot long piece of wood, there should be a gap from the top of the soil to the bottom of the 2x4 by 6 inches. You need to grade the soil away from the house. You'll note in this illustration, it shows a gutter. When the rain comes down through the gutter, it discharges right there by the foundation, doesn't it? And what we need is the grading of the earth to move the water away from the earth, not to allow it to be reabsorbed right next to the foundation. This is why many gutters have extension pipes on them for an additional 6 or 8 feet to have that water from the downspout and the gutters discharge 6 to 8 feet away from the house. So they'll put an extension pipe on the downspout because the water's coming down the gutter into the downspout, and you want that to go away from the house. You want your soil line to be high up against the house and grade away from the house to encourage moisture to remove itself from the foundation of the house. This is a really good piece of information to understand due to the fact that many basements do suffer from some form of moisture or another. Very common. Let's look at page 64. On page 64, we're going to talk about different types of framing. There is what is known as balloon framing, and there's what is known as platform framing. And that is when the joist is embedded into the vertical part of the framing. It's a much more sound type of framing. See how it recesses in to the vertical stud and the headers. Different types of joist you'll see on the bottom. And we talk about joist in the basement a lot. Floor joist, the wooden joist, they're saying here are 2 by 8s by 10 by 12 by 14. If we're talking about our standard 2-story, 3-bedroom, 1-bath home in South Philly, the home inspector is going to measure the width of the house in the basement. He's going to see how wide is his house. He is then going to measure how tall is this joist and how thick is the joist. The greater the height of the joist and the greater the thickness of the joist allows for more weight to be held. So it's pure physics. Many years ago, I listed a home, a vacant property in Fishtown. And it was, oddly enough, a single family home. Very strange, off of Frankfurt Avenue. Also a very old home. As I walked into the home was at least 18 feet wide. And as I walked from the front door through the living room, entering into the dining area, I noticed a sloping when I walked in there. The home has circular staircase to get into the basement. When I got in the basement, there I found about 8 or 10 jacks holding up joist, floor joist. I looked at the floor joist and said to myself, oh, wow, these are really weird. They were the length of the house, but they were very shallow in height. They may be only 8 inches or 10 inches tall. They could not hold the second floor weight of the house because they weren't strong enough. Therefore, the flooring was giving away, hence the dipping I was feeling. They had jacks under the house holding that house up interiorly because the quality and sizing of the joist were not enough to hold it up. So the greater the size of the joist, the greater the weight they can hold. In our two-story, 3-bedroom, 1-bath house in South Philly, built 100 years ago, the joists are extremely thick and will hold any and all of their weight, possibly even an additional 3rd story if an engineer deems that the joist structure is sound enough to hold that. So that's really important. It shows load-bearing walls. As an agent, you're going to have buyers say to you when you walk through a house, if I could only remove this wall, this house would be perfect. And they're going to ask you, can I take this wall out? Well, that question is never to be answered by a real estate agent. That is above our pay grade. The answer to that question when asked by a potential buyer is, I don't know that, but an engineer or an architect could tell you that. So there are ways to remove walls and add what is known as a lintel or a header to add additional strength for the weight above, but none of that is our pay grade. We are not of the quality to do that. Money will fix everything. So if someone wants to spend the money to have a wall removed that is a weight-bearing wall, there are ways to allow that wall to be resupported in another way so that the weight above it can be properly supported. There is floor truss systems. Now that you're going to see in attics, a truss system that looks like the letter W and how it's structurally built. We're going to talk about subfloors. There are various types of subflooring in a home. So it's typical to see 3/4 inch subflooring and then maybe 3/4 inch hardwood flooring above it. The flooring today is desired to be that of hardwood, and hardwood flooring comes in different grades and thicknesses. So always the thicker would be the better, right? But you need a subfloor before you can put a hardwood floor. Talks about different types of beams. There's laminated veneer type of lumber, different kinds of manufactured glued lumber, solid wood lumber, an I-beam made out of metal, and that looks like the letter I. And then there is a build-up type of beam that is a construction. We see mostly I-beams, solid wood is primarily what we see in construction in this area. Look on page 66, and we're going to talk about on the top here, headers. Now, I saw a commercial years ago, and the narrator made a very interesting comment. The commercial was to sell windows. It was a window company. And they made a statement. And the statement was, windows and doors are nothing more than holes in your house. And I thought, oh my God, that's so true. Windows and doors are holes in our house. So let's look here on this artist rendering Where it has a rough window opening, it looks like it would be the front window of a home. And above that is what is known as a header. That's a big, heavy piece of wood that's put above a hole in the house. You'll notice where they have the rough door opening, they have a header again. Headers are there to support the weight above the hole, either a door or a window. It's important to learn some of this terminology so you can speak intelligently about the right wording for what you're trying to get across. You'll see the 2x4s go vertically in between here. Double studding around any opening, so around any hole, there will be double studding. You can obviously see this if you take the time to walk through any type of new construction. On the bottom where it talks about brick, you'll see I have the word pointing. Pointing is when the mortar between the bricks has been scraped to remove any loose or missing mortar, and mortar has been replaced back in there, in between the joints. They are called joints. And you'll see that when you are looking at a property on the exterior and the mortar between the bricks is thicker than the house next to you. The house next to you, excuse me, has never been pointed. And the mortar is much thinner. It's the original mortar mix that was used when the home was built. But your house that you're showing has a much thicker mortar. And that's due to the fact that that was replaced. Old mortar, loose mortar had been removed and scraped out, and new mortar had been put in there to prevent water from penetrating behind the brick walls. Remember, when water gets behind something, it freezes. And when it freezes, it expands. And when it expands, it's going to crack. Okay? Masonry walls have to have a weep hole. And you're going to see that in masonry construction, brick construction, where you'll see a small little gap, maybe 1/4 of an inch, where there is no mortar. And it's sort of in a pattern. That is the weep holes. So that from the top by the roof line, if any water gets behind the brick, gravity's going to pull the water down, and it's going to have a place to escape from the weep holes. When we look on the next page on 67, we see a brick home. Now, the brick home has a window. The window is a hole in the house. They don't have headers there. They have lintels. Lintels are made out of metal, and they extend further out to the left and to the right of the hole where the window is to support the bricks above them, above that hole, right? Because there's a voided space there. So something has to support the bricks above them, and that's where that lintel is inserted when the home was built, extending beyond the hole to hold up the bricks above them. Does that make sense? Now we're going to speak about stucco on page 67. Stucco can be a real problem. Old style stucco that's been around 35, 50 years, old time stucco, that was put on carefully with a mason can be a fabulous thing. It still has to be maintained, right? Because it's masonry, and masonry items do deteriorate over time. But modern stucco can be a real problem in that there are a lot of shortcuts taken, and therefore the stucco becomes absorbent and takes in water where it should not. There should be a sheathing. There should be perforated casement beadings, paper and wire mesh, 3 coats of stucco finish. When stucco becomes absorbent and water gets behind the stucco, it can cause mold and mildew. If you are the buyer's agent and you are representing a buyer, you must insist in your due diligence to have a stucco inspection done to the property. Stucco inspections are not done by the home inspector. They are done by a licensed professional that does only stucco inspections. It is an invasive procedure due to the fact they actually drill teeny tiny holes into the side of the property through the stucco to insert moisture meters to see if there is any moisture around windows and doors. Remember the holes of a home. That is primarily where water can penetrate. If moisture is found in a property, the repair can be extremely costly. This is why the buyer can't be frugal here. They need to spend whatever it costs, $300, $400, to have a stucco inspection done to confirm that the property is not in a deficient state as far as the stucco is concerned. Let's look on page 69, and we're going to talk about double hung windows. Now, we briefly talked about double hung windows last week in the very beginning of our class regarding lead-based paint. Double hung windows, the illustration here shows how the bottom sash can go up and the top sash can be pulled down. The issue is that there is friction between the two sashes in the up and down motion. The up and down motion is where the concern happens with the friction of lead dust coming off the paint and floating down to the floor because lead is heavier than air, and having a small child get it on their hands and ingest it. This also talks about double hung windows. The old-fashioned type often had bilaterally on either side of the window frame, inside the wall, were weights that would hold the window up or hold the window down. Those weights were sometimes supported to the window by rope, which would deteriorate and the weight would fall and break, or by chain, which was the better way. If a weight was to break and the window would not open properly because it was off balance with the weights inside the wall, you'd have to open up the wall, reattach the weight to the string, the rope and or metal chain link and then repatch up the wall. So we're talking about plaster walls here. We're talking very old windows. But that's how they balanced them, was with weights in the old time windows. We turn to page 70, garage door. Not, there are garage doors in Philadelphia, not like they are in the suburbs, but we do have them. And it talks here about how the chain and the motor of the garage door opener pulls the garage door open. The most important part here of a garage door opener is at the bottom. At the bottom where there is a I-beam sensor that goes across back and forth between the two sensors on either side of the garage door. These sensors are in place so that if the beam of light is interrupted while the garage door is coming down, it will halt the garage door from continuing its mission to come all the way down due to a pet, a ball, a child, whatever, interrupted that beam. It is a safety concern. So during your home inspection, your home inspector will be having the garage door open and closed, and on its way coming down, will throw his leg across the beam to make sure that that garage door opener is operating properly and cease and desist if the beam is interrupted. Talks about the control button, usually right there by the interior door into the garage, so you can open and close the garage. And then it talks about if you have to manually close the garage door, if for some reason the opener fails to work. We go on to page 72, and we're going to talk about roof ventilation and insulation. Different grades of insulation in an attic needs insulation. But what a lot of people don't realize is the attic has to breathe also. We can't close the attic so there is no airflow. A basement who holds moisture can be identified when a home inspector peeks up in the crawl space and looks around the nails coming through the roofing material. They look at the nails coming through the roofing material and will note dark wood darkening around each nail. That's telling the home inspector that the basement holds water. And you're like, how the hell does that happen? The moisture comes up through the basement, through the first and second floor, and works its way up into the crawl space and has nowhere to go because the attic has been sealed off. It's been sealed off with the thought process that it's keeping cold air out. What it's doing is preventing moisture from escape. So all attics and crawl space have to have ventilation. And that's where you will see they have roof vents, and they talk about the roof vent. It talks about insulation here on wall sections of a framed roof. R19 fiberglass is needed in the walls. Talks about a vapor barrier that is needed to protect insulation and structure from moisture. And that should be in the attic space. Talks about different types of attic ventilation. Now, we saw on page 72 a roof vent, a circular type of roof vent on that Cape Cod. And we also see a different type of venting on page 73. We have an attic ventilation known as a roof vent. Very common to see that on your A-frame roofs. Right there at the very top, that entire ridge at the very top is to allow moisture and airflow to come in and out of the attic space. And then there are different types of roof vents that are vented out in a closed system, such as like the dryer vent kind of look, you know, that closed flexible hosing that will allow moisture to go in and come out through the attic. Very important. Many of the rehab homes today on page 74 talk about bathroom vents. Bathrooms have windows. Ah, yes, to ventilate. But when we rehab, we decide we're going to put a powder room on the first floor between the kitchen, dining room, or maybe the kitchen and the living room. We throw in a powder room, but there's no exterior window. That powder room has to have a venting system. And when the home inspector's there, he's going to check the vent to make sure the venting system is working in the powder room. But the real question is, does that fan vent, into the attic, or does it then have a flexible piping that is attached to a permanent exterior vent on the roof? So it actually vents outside. And that is ideally how it is to ventilate out, not to ventilate just into the attic space. Let's look on page 75, and it's going to show us different types of roof venting and terms. Now, these terms are important for you to understand so you can learn about and understand what the home inspector is speaking of. On the illustration of roof terms on 75 on the bottom, we've got your plumbing vents, and we spoke about them, right? Venting for the sewer gases. We have a hip, which is that angle on the roof, the hip. Chimney flashing, very important. Chimneys are very important to the safety of a home. So we have to make sure that our chimneys are functioning properly. We have eaves, and that's the area where the roof stops and goes around the perimeter of the roof. A valley, where two different angles meet on a shingle roof. Skylights, roof vents. So we're showing here that this property has venting on the roof here. Talks about a gable, which is an angular part of the roof. We have the roof ridge at the very top, and then we have the roof vent. So we spoke about a few pages ago for roof vents that run all the length of the roof and are vented underneath. So water doesn't, when it rains, water doesn't go in it, but air can flow and escape through those ridge roof vents. It talks about a valley. A valley is the angle where the dormer roof meets the main roof. It talks about step flashing. These are all words you should become familiar with by reading the book and understanding when you're reviewing your home inspections. Talks about some different types of roofs known as gable, gabriel, hip, shed, Mansford. On the next page, we're going to talk about on 76, different types of shingles. There are wood roofs made out of cedar shake roofing. Rare to see that, but these do still exist. And it talks about how the proper installation is needed. They talk about a tile roof, which would be a ceramic tile roof. We talk about the tile roofs on page 77, which are those arched terracotta type, southwestern type of look roofing. And then we talk about a flat or low slope roof known as a rubber roof. Philadelphia is loaded with flat roofs. The pitch of a flat roof is minimal at best. You'll look back on page 75, and it talks about the roof sloping on the bottom right of 75. And a membrane roof, and that would be your rubber roof, can be 2.5 inches to 4.5 inch slope, which is quite a minimal slope for the rain to hit that and then make its way down to the back of the roof where the box is, where the roofing water, the rainwater, has to go to the box. It's pitched to that direction and runs down the gutter. That's where the back bedroom in a row home is so important to check the roof. That is where, if there has been a clog in that roofing box back there, that is where the ceiling's going to leak. And that's where we're going to see discoloration in the ceiling of the roof in the back bedroom. Real important. Let's talk about a chimney on page 78. I've touched on chimneys a couple times, but the importance to understand about chimneys are huge. If you look at the illustration on 78, it shows on the bottom left where it says heating plant. So they're talking about the heating device. And let's say it's a hot air system. That hot air system has that stack, that aluminum circular pipe on an angle going to the chimney, along with the water heater in a gas home has to go to the chimney. Both of these are going to enter and feed into the chimney. The chimney liners is where the concern happens. So, way back, hundreds of years ago, when homes were built, the chimneys were built of brick, and that's all that happened. They just built the chimneys of brick, and they had a voided space where the the CO2 and the smoke, because they were cooking in these chimneys, right? These large chimneys and these large fireplaces, where all of that went up and out of the house. All right. Then we realized that in the 1900s, chimneys were built with no liners, and they decided that they needed to line these chimneys. And they lined them with a clay type known as terracotta. And a clay sleeve was added to the inside facing of the brick. So they built the chimney, and as they were building the chimney, they were sliding down these terracotta sleeves. So now there was an additional protection from where the interior of the brick was and where the gases and poisons were leaving the house. Both brick and terracotta, though, are made of earthenware. Terracotta, you know, is that orange pot when you were a kid in elementary school, would plant the bulb for your mom for Easter and you'd bring it home. But if you dropped the pot, it shattered. That's terracotta. Terracotta is very brittle. And because the airflow in a chimney can be either cold or hot, it's going to expand or contract. Hot and cold, hot and cold, hot and cold. Over time, that's going to change the integrity of the terracotta. So what can happen is it weakens the terracotta and it could fracture within itself. And when it fractures within itself, it may tip in towards the center of the chimney, preventing airflow or inhibiting airflow. It may bounce off the other wall and just leave an inch or so for the air to force itself through instead of that bigger opening of 4 or 5 inches it had before. So they realized that that's not working too good either. So chimneys now are lined with a metal lining looking very similar to your dryer vent, except much larger in size, to line inside the chimney. The stainless steel liner is not affected by heat and cold. Therefore, the integrity of the stainless steel is not going to change over time. Where the terracotta, it does change over time. So it's important to make sure that your home inspector does a thorough examination of the chimney. Talking about the very top of the chimney, known as the cap. In a lot of old chimneys, that's masonry, where it has great deficiencies and will probably need a lot of masonry repair. He wants to look down the chimney to make sure he doesn't see any obstructions. And they want to look up the chimney where the clean out is to make sure the airflow is sufficient to take the carbon monoxide up and out through the chimney. Talks about metal chimneys on page 79, which you will see if somebody perhaps has a gas fireplace they've inserted, or perhaps a wood burning stove. They'll insert a metal chimney either through the home, as the illustration is on page 79, or along the exterior of the home to allow the carbon monoxide gases to expel. I hope this has helped you understand a little bit better about the mechanics of a home. Again, I'm strongly encouraging that you actually read the entire book to get a better understanding of the different chapters we reviewed and to help you understand much better on your next home inspection report. Thank you. Have a good day.
Thanks, Vicki.
Bye.
Thank you. You too.
Thanks, Vic.